Well, now let's see some practical example based mainly on the technique to be used for reinforcement of openings. So let's start with a vessel R001. This is a vessel for the moment without nozzles. Let's look it at from a different point of view. Now it's a little bit nicer. And now let's see the characteristic of this item. Properties. The code is ASME 8 Division 1 Edition 2023. It's a horizontal vessel made of carbon steel, mainly of carbon steel. The units are megapascal and degrees centigrade. Now then we want to see the design conditions. Design conditions are temperature 150 degrees, pressure, design pressure 1.5 megapascal, that is 15 bar, joint efficiency 0.85, 1 millimeter corrosion allowance. And now let's look at, we want to place on the shell some openings. The shell has a length of 6 meters, a thickness of 18 millimeter, a diameter of 2.5 meter. Let's look at the preliminary report. The required thickness for these conditions is 17.12 millimeter, and the under tolerance used is 0, because according to the ASME code, if the tolerance is smaller than the minimum value between 0.3 millimeter and 6% of the thickness, you have not to take it in consideration in your calculations. In this case, the tolerance of a plate of SA516 grade 70 is 0.25 millimeters, so you must not take it into account. Okay, having seen the conditions of this shell, the geometry of this shell, we want to place on this shell a nozzle of 14 inches nominal diameter. So let's, the components, we take a nozzle. We want to place the nozzle on the shell. In fact, you have seen that the shell is yellow, that means it's active. The nozzle is made of A106 grade B, because this is the normal material considered in the set of materials that I have given at the beginning. The nozzle type is set in. We must define the nozzle height, say 400 millimeter. Nozzle thickness, we must not fill this value because it's filled automatically if we open the database. Note that the first attempt to do when you have an opening to be reinforced is to reinforce it considering only the pipe thickness. The pipe thickness of the 14 inches, that's this one. Let's consider the extra strong type, so select. So all the dimensions have been automatically filled. We must still define the position, so offset from shell border, say 1 meter from the shell border. Angular offset is 0 because we want to place it towards the north. There is an under tolerance for the nozzle, 12.5, but note that according to ASME 8 Division 1, when calculating the reinforcement of an opening, you must not take this value into account. There is no reinforcing pad for the moment. Let's see what is missing. leg of nodal to fillet weld. Let's say that if the shell thickness is 18, an appropriate value for this leg is 15 millimeter. And now we will see at once that the reinforcement is not sufficient, because you have a required area of 4,500 and something square millimeter, while the available area is only 1,700 and something. We could try to use a higher thickness, but if we look at the database, for example, there is not, after the extra strong, there is no double extra strong pipe. Take into account that when using pipes as reinforcement, you must also take into account that generally it's not possible to buy a small piece of pipe of 500 millimeter. You must buy a standard length of 6 meters. Of course, to find the standard length on the market, you can easily find the extra strong, maybe also double extra strong pipes, but no more than this. Just to have a look of what happens, just increasing the pipe thickness, we take, for example, a pipe schedule 80, select, and then we see that even with this higher thickness, it is not possible to reinforce the opening. The best solution is to come back to the standard pipe size, the 12.7 millimeter thickness, and to add a reinforcing pad. The pad, you may design a pad starting from its outside diameter, or have a particular card for the pad. We don't want the outside diameter, we want the pad width. Say the pad thickness is the same thickness as the shell, 80 millimeter. The pad width we may take 100 millimeter. Pad under tolerance has not to be considered. Pad material, we take the same material as the shell. Now, there is some more dink to be considered, because, okay, this is the leg of the pad, the leg of the weld, which connects the reinforcing pad to the shell. We take also 15 millimeter for this characteristics, and then you see that the opening is reinforced. We look at the preliminary report and we see that the area required is 4,500 and something. Now the total available area is 5,700. We could possibly reduce the pad width, but I mean the cost is not the cost of a reinforcing pad is mainly tied to the man hours needed to weld the pad to the shell. So we accept this solution, and now we will see our nodal. So it's better to make a different. Okay, now we can see it a little bit better. Well, now we want to check if it is possible to make the same type of reinforcement using a long welding neck flange instead of using a pipe. So we select first of all we must select the shell where we want to place the long welding neck flange. Then we select the long welding neck flange, and we look at some decision that has already been taken by the software. For example, the material SA105, that is a forging. the type of connection is set in. Length, well, better to say height of the long welding neck flange outside the shell. We take 500 millimeter. All the dimension depends, these dimensions depends on the standard. We check standard flange, what it is possible. First of all, we must decide what type of database. We want an ANSI or better NASME B165, and the class should be at least 300. We take the same nodal diameter, so 14 inches, and then we also put a check here, disable bolt and gasket validation, because we are only interested in the reinforcement of opening. We do not intend to check the flange, the gasket, etc. So we have still to design the position of this, always oriented to the north, but of course to make a certain distance in respect of the preceding nodals. We say 3000 millimeters from the edge. Let me check, well, there is something more. The leg of nodal to wall fillet, say, also in this case, we say 15 millimeters. And now check, well, okay, the standard thickness of that pipe, of the long welding neck flange, is not even adequate for the reinforcement of opening, because the required area is 4,800 and something square millimeter, while we have only 4,100 and something. I mean, the possibility should be to put a reinforcing pad, but it would be a very stupid solution, because we want to use a long welding neck flange just in order to avoid a reinforcing pad. The other solution is to increase the thickness of the pipe of the long welding neck at the connection with the shell. But this would mean to make a non-standard long welding neck with an increase of cost. The advantage of the long welding neck is that it is practically a standard piece of equipment that you can order according to the specification of the manufacturer without problem. But if you require something different, this becomes something special and the cost will increase. Let's see if there is some other possibility. In this general, there is the possibility of using the rules of Section 8, Division 2. It is the Appendix 46 of ASME 8, Division 1. Well, when we set this thickness, when we set this thick here, well, we see that suddenly the nodal is verified. Let's check at the preliminary report. The preliminary report now is based mainly on the average primary local stress on the reinforcing area. And so you see that this maximum local primary membrane stress is 132.68 against an allowable stress, which is 1.5, the standard allowable stress because it is a primary local, which is 175. So everything is okay, and our flange has been properly designed. One should think at this point, why not try to use also for this nozzle the rules of the section 2, that means to use appendix 46, just in order to avoid the reinforcing pad. So first step, under general, we put a tick here, use section 8 division 2 rules. With the reinforcing pad, no, it's not that it is not sufficient. The only problem is the weld, because the weld must be a little bit increased. And if you want to see where is the problem, no, sorry, we have not to accept this, we have only to see where it is. So we put 16 millimeter and 16 millimeter also here, but the problem is that we want really to eliminate the pad. No pad, no reinforcing pad. Let's see what's happening. The required, the allowable stress is 175, while the actual stress is 340. In this case, it is not possible to use the division 2 rules. We come back to the pad. We put again our pad here with the same dimensions as before, and it is also possible to eliminate this tick from this card here. Well, let's make a further check to see what is the weight of this vessel, a vessel composed by one cylindrical shell with 2 domed ends and 2 nozzles like that. What is the weight of this vessel? Item properties. The total weight is 8,747 kilograms. Now we want to see what happens with a similar vessel manufactured according to the harmonized standard EN 13,445-3. We close this item. Let's try to make a similar exercise on a similar vessel manufactured and calculated in accordance to the harmonized standard. This is the vessel, which for the moment is composed only by a cylindrical shell and 2 domed ends. Let's see it a little bit better. And let's look at the characteristics of this vessel. Item, properties. You see, the design standard is EN 13445-3 edition 2021. The situation from the point of view of the design data is exactly the same. Design conditions, temperature 150, internal pressure 15 bar. Corrosion allowance 1 mm, joint efficiency 0.85. Now we will try to put on this vessel a nozzle made from a pipe with a diameter, nominal diameter of 14 inches. Components, nozzle. We have forgotten to specify where we want to put this component. So this is a nozzle. We want to place it on the cylindrical shell. The nozzle is made of a carbon steel material according to an EN standard 10,216-2. The tolerance is not an absolute value. In this case, the tolerance is given as a percentage, 12.5%. The nozzle is set in. The database of the pipes, we see this is the 14 inches. We take the extra strong thickness. So everything, now we have to specify the height, say 400 millimeter. And for the time being, what is missing? The distance from the shell border, say 1 meter. And we see at once that, let's look at a preliminary report. The preliminary report, now the calculation is based on the reactive force and the pressure load. So the reactive force is 499,000 Newton, and the pressure load is 673, so it is much higher. We can try to see if it is possible to increase a little bit the thickness, so to use in the database a different thickness, a different pipe thickness. The double extra strong does not exist. We just, to make an attempt, we try to use a schedule 80 pipe, but then you see that the situation is not changed. The reactive force is 585,000, but it is always lower than the pressure load, 676,000. The only solution is to use the only solution. Of course, there could be another solution than using a reinforcing pad. And then we will see with the long welding neck. In the database, we come back to the 12.7 thickness. We now use a reinforcing pad. A reinforcing pad, there is a particular card for the pad. We don't want to use the outside diameter, but the pad width. Say a width of 80 millimeter. The pad thickness, I forgot to see one thing, that the thickness of the cylindrical shell is not 18, it's 13 millimeter. So 13, pad material is exactly the same material of the shell. And now we see that everything, almost everything, is okay, because we have in the longitudinal check, reactive force is 685 and the pressure load is 673. So it's just a little bit. I see a yellow warning. What is the warning? Nozzle with a longitudinal weld. So we have forgotten one thing. The joint efficiency has been used for all the components, so also the nozzle has been penalized with the joint efficiency of 0.85. Therefore, it is enough to disable this, so we look not in geometry, in design conditions. To disable this 0.85, we replace it with 1, and then the yellow warning should disappear. Only do we want to apply this change to every component, and no, I want to apply this only to the nozzle. Now, let's see if it is possible to use a long welding neck as we made in the other vessel. So we want to place long welding neck on this shell. By the way, we have not seen it before, but the characteristics of the shell is that the thickness is 13 millimeter, diameter and length are exactly as in the other vessel. Now we want to take a long welding neck, which is made of forged materials according to the EN specification P280GH. Nozzle length, we can use, for example, 500 millimeter, considering that there is also the flange. Flange thickness, this is flange outside diameter. Well, the inside diameter, I think we have to consider a 330 millimeter because this is required by the standard. Now, standard flange, we can use our database. The flange should be a flange according to EN 17059. It is similar to ASME, and this is exactly the same as ASME B161. We can use a 14-inch, but no class 300. The classes are exactly as in the ASME flanges. Now everything should be defined. In fact, you have seen that there are all the thicknesses. What is necessary is to fix the position. The position should be, we should put it at 3 meters from the shell border. Position is radial. What is missing? Well, we do not want the calculation of the flange as a flange. So we must disable bolt and gasket validation in order to consider only the reinforcement. There is still a yellow warning because everything is okay, but let's look at the warning. Selected thickness 54 is outside material size limits. Okay, this depends on the fact that when the program selects a particular material and the particular material has different classes of thickness, the computer, the software takes always the lower class, and in this case the class which was taken is from 0 to 35 millimeter, but here we have a thickness of 54, so it's necessary to use a higher class of material. Selecting this material, the warning will disappear. And so now we will have also our long welding neck flange on our shell. Standard long welding neck can be used without particular problems. What we want still to see is something about the item properties. And exactly we want to know the weight. The weight of this vessel is 6,559 kilograms. If I remember correctly, the ASME vessel had a weight of 8,500 kilograms, more or less. So there is a difference of about 2,000 kilograms between the vessel fabricated in accordance with ASME 8 Division 1 and the vessel fabricated according to EN 13445-3. Of course, the difference is not due to the two nozzles that we have added, because the two nozzles are more or less equal. The difference is mainly due to the thicknesses of the shell and of the ends, which makes a big difference. Well, with this, I can close my presentation, and I thank you very much for your attention.